Let's be real. Data science. You hear that term everywhere, right? It's the hottest job, the secret sauce for big tech, basically the future of everything. But what if I told you the story we all know about its origin is, well, mostly wrong? Turns out this supposedly new field is actually built on a secret 50-year-old rebellion. So let's dig into its real history. And this is not just some academic buzzword. I mean, look at this number. In 2015, the University of Michigan announced a $100 million data science initiative. When you see that kind of money being thrown around, you know it's not just hype. It's a signal of a massive, seismic shift in how major institutions see the future. And it's not just about the money. The claims being made are absolutely huge. They're calling it the fourth approach to scientific discovery. Think about that. They're putting it on the same level as the classical scientific method. The stakes couldn't be higher. It's being framed as a total revolution in how we learn about the world, which, of course, brings us to the central mystery. For all the cash, for all the hype, nobody seems to have a straight answer to these simple questions. In fact, this confusion has created a huge identity crisis, and that's really where our story kicks off. Okay, first up, the data science moment. To get to that secret history, we have to start with the mess we're in today. We are living through a period of intense confusion and conflict over what this field actually is. Just take a look at the official definitions from the Data Science Association. A data scientist, quote, creates meaning from raw data. A statistician, quote, collects and analyzes numerical data. Do you see the problem here? They sound almost exactly the same, and this vague, fuzzy language is right at the heart of all the confusion. And this quote, wow, it just nails the feeling within the statistics community. The president of the American Statistical Association asked this question in 2013. You can almost hear the frustration, right? They're watching this new, flashy field get all the credit for doing the kind of work they've been doing for centuries, and they're just thinking, hey, wait a minute, isn't that us? But then you hear this from the other side. A really prominent data scientist, who is also a statistician at Columbia, says statistics is the least important part. So, okay, this clearly isn't some simple branding issue. This is a deep, philosophical fight over the soul of the field. All right, section 2, busting the big data myths. So when people try to solve this puzzle, they usually point to two big things, big data and a bunch of new skills. Let's take a look at why both of those explanations are really just myths. This is the number one explanation you'll hear, that data science is just statistics, but for massive internet-scale data sets. It sounds simple, it sounds clean, but if you look at the history, it just doesn't hold up. Yeah, the history tells a totally different story. The word statistics itself was literally coined to describe analyzing massive government census data. That was the big data of the 19th century. And get this, a statistician invented the punched card reader, the very machine that led to the founding of IBM specifically to handle all that data. So no, statisticians have always been in the big data game. Okay. So if it's not just the size of the data, maybe it's the tools? You know, all those specialized computing skills like Hadoop or Spark that you need to handle these giant, messy data sets? Well, as Stanford's David Donoho argues, these aren't really new scientific principles. He calls them coping skills. And that's a perfect description. They're basically just workarounds for dealing with today's incredibly complex and frankly kind of clumsy computer systems. They're engineering solutions, and they don't necessarily mean you're getting any deeper insights from the data itself. So, if it's not about big data, and it's not just about a few new programming tools, what on earth is it? This is where we finally uncover the real story, the secret history that started more than half a century ago. I want you to meet John Tukey. He was an absolute genius, a statistician at Bell Labs. And way back in 1962, he published this paper that was essentially a declaration of rebellion. He felt his own field had lost its way, becoming obsessed with pure math theory and forgetting its real mission, to actually learn from data. He called for a brand new science, and he named it data analysis. And Tukey wasn't some lone voice in the wilderness. This idea kept bubbling under the surface for decades. In '93, another giant from Bell Labs, John Chambers, warned his colleagues to think bigger. And then, in 2001, the statistician Leo Bremen finally put a name to the schism he saw tearing the field apart. He called it the two cultures of modeling. And this idea of two cultures is absolutely crucial. The first culture, that's traditional statistics, they focused on inference. They wanted to build a model that explained how the data was generated. But the second culture, which we'd now call machine learning, they cared about one thing: prediction. They didn't really care why a model worked, as long as it gave them the right answer about the future. It was a fundamental split in their whole philosophy.
So, building on this 50-year-long intellectual journey, we finally get to a definition that actually makes sense of everything. It's a framework called greater data science.
See, greater data science isn't just one thing. It's the entire process, a 6-part workflow. It starts with the really hard, unglamorous work of cleaning and prepping data, moves through computing and modeling, all the way to visualization. And then there's that final, profound step, turning the tools of science back onto data science itself. But here is the problem. Most university programs today aren't teaching this big picture. They're teaching what Donoho calls lesser data science. They zoom in and hyper-focus on just one tiny piece of the puzzle: data modeling, the machine learning algorithms. And this means they're often completely ignoring the other 5 areas, which is where most of the actual work happens. And this iceberg metaphor is just perfect. The fancy algorithms that everyone talks about, that's just the tiny tip of the iceberg you see above the water. The massive hidden part underneath, the part that takes up like 80% of a data scientist's time, is all that other stuff: the exploration, the cleaning, the preparation. Greater data science is about understanding the entire iceberg. And that brings us to the last, and honestly, the most revolutionary piece of this whole story, that 6th division: the idea of creating a science about science itself. So what does that actually mean? It means we start treating the entire body of scientific knowledge, every single paper, every study, every data set, as one gigantic data set itself. And then we can use the tools of data science to analyze the scientific process, to figure out which methods are actually reliable and which ones might be leading us down the wrong path. Just think about the possibilities. We could automatically check if the findings from one study hold up when you compare it to data from 1,000 others. We could spot systemic biases in entire fields of research and then fix them. We could build a scientific enterprise that's more robust, more reliable, and ultimately more truthful. So, you see, the true history of data science isn't really about hype or big data. It's a 50-year quest for a more empirical, more honest way of learning from the world. And its ultimate promise isn't just about better gadgets, but a deeper understanding of science itself. Which leaves us with a final, pretty mind-bending thought. If science itself becomes data, what will we learn about the nature of discovery?